Yep. It says sending data. So I think we're live, Mr. Smith. Mr. Smith, Mr. Smith. And so we should check. I should check just to make sure that we are live.
That's a good idea.
I've done this before and I wasn't live. So LinkedIn says live. So I'm sure if I'm live on LinkedIn, I am live on Facebook or YouTube, both. So welcome everybody. It is 5 o'clock. It's 5:02. We're 2 minutes late because we were just talking. So
hanging out.
Yeah, we were hanging out, and I said, "Boy, David, I think I should hit the live button." And he's like, "Yeah, Tom, I think we should." So, and I got your file that you just sent me. So, welcome everybody. Today, you know what, David? It is Electrical Safety Month.
You know what? I woke up kind of wondering what that feeling was, and that's what it was.
That's what
You're
it was.
absolutely right.
It's like a tingle, isn't it? Like in your stomach?
Yeah, it's like, it's the good kind of like, I don't know, vertigo. But a good vertigo.
It's a good vertigo.
Like you're dizzy, and it's just like, man, finally, I've been waiting 11 months for this, and it's finally Electrical Safety Month.
It's finally Electrical Safety Month.
It's Christmas in May.
It's Christmas in May, and what a great May it is because, you know, last year, hey, we got Felix Sandoval in the house. Thanks for joining us, Felix. So last year we had Shock Week, and Felix got one of the most expensive mugs I've ever mailed to anybody, and I love it. I love it. But we had Shock Week, and we're not going to repeat Shock Week. We're not going to do exactly what we did last year, or what I did last year with Nihad El Sharif, right? So in fact, Nihad and I were talking on Sunday a little bit about doing a program with him. I'm calling it the Buck 41 Club. And I still haven't shared that with the world yet. Stay tuned for the Buck 41 Club.
Stay tuned.
Yeah, it's going to be good. So in any case, we're going to do something different because I want to talk about the hazards. We want to talk about technology. We want to talk about where the National Electrical Code is, where it's going, and then a little bit about the future. Yeah, with or without Shock Week mug is TSDN. You know what TSDN stands for, David?
Ooh, let's hear it.
Well, so we were live last year, and you know me, I want to make up stuff. I mean, we're engineers, so we come up with acronyms. TSDN is Technical Social Distancing Network.
Love it.
Yep, I was going to do SDN, and then I Googled it, and then that was already taking. Social Distancing Network is already taken, so then we said, hey, let's throw technical in front of it, and that's what we did. So, shock, electric shock. So I had a call from Robert today from Omaha.
Okay, all right.
And he said, hey, I saw your little tickler in the morning, and he said, he goes, you know, shock. He raised a good point. He goes, what is shock? And I didn't know where he was going. I'm like, well, shock is, I mean, I'm in shock now. You're asking me what shock is. What is shock, right? And he made a good point that shock is trauma to the body. Okay. Right? And when we talk about electrical shock, we're talking about electrical trauma to the body. It means current is passing through the body, and we receive the magnetic forces of that current, right?
Sure, absolutely. I think that's a great way of summarizing it.
Yeah, and it doesn't matter. Remember, current takes how many paths? Current takes all paths, right? And if you're a part of that, then a percentage of the current that is flowing, because you may be in parallel with an equipment grounding conductor, you could be in parallel with the earth.
That's right.
You can be in series with all of those too. But current will find its way through just about anything. So I just downloaded your file.
Great.
But I'm going to try to call that up and just make sure it's ready in case you say, hey, Tom, take a look.
Just in case.
Just in
case.
Right.
This is a live production, ladies and gentlemen.
And you know what? There is a lot to be said about going live.
That's true.
So NFPA 70E talks about shock, or yeah, the shock hazard, right? And I'm just going to look real quick and try to take a look at what does 70E define shock as. Shock hazard. That's the other thing is we're not talking about shock. We're talking about the shock hazard, right?
Got it. Absolutely.
Yeah. So, 70E defines the shock hazard as a source of possible injury or damage to health associated with current through the body caused by contact or approach to exposed energized electrical conductors or circuit parts. Make sense?
Yeah, I mean, that's a very succinct way of going about it. Is that only in 70E, or is there also a definition elsewhere in other LFPA codes?
I don't believe that. Oh, you know, I don't believe there's. This is a good question.
Thanks.
You get those every now and then, don't you? So here, you know what? I have a subscription to this NFIRS, right? So
Oh, okay.
I can. Oh, I get. Gotta figure out how to get out of this.
I would guess that is defined only in 70E. I think. You think that's a fair guess?
Yeah, because a 70E is a the electrical safe work practices, right?
Right.
So now that term shock hazard is used. We'll put quotes around this. Shock hazard is used in various documents, and it's probably only defined. It's used in the National Electrical Code, in NFPA 79, NFPA 70B.
Really? Okay.
Yep. So we use the term a lot in the National Electrical Code and other documents, but I would say it's probably the key definition is going to be 70E.
Mm-hmm.
And you know, Annex K of 70E has a lot of good information. Do you have a copy of 70E, David?
I do not. I have currently right beside me the 2020 code, and I have the absolutely illustrious analysis of changes.
Oh, from the IAEI.
Well. That's
excellent.
Right.
Well, I'll tell you what. So in Annex K, informative Annex K, general categories of electrical hazards.
Sorry, there's a cursor flying around here. Sorry.
There's a cursor. Oh, there it is. There it is. Yeah, let me move that out of here.
All right, perfect.
It was a cursor. It was a hand.
It was a cursory.
It was a cursory hand. So in Annex K, what I find really interesting is Annex K tells us, you know, when people talk about 70E, what's the first thing that comes to your mind when I say electrical safety, electrical safe work practices 70E? What is the first thing you think about?
PPE and arc flash.
That's exactly right. That's the first thing everybody thinks about. But in reality, the Bureau of Labor Statistics indicates that there were nearly 6,000 fatal electrical injuries to the workers in the United States from 92 to 2012. There were 24,100 non-fatal electrical injuries from 2003 to 2012. And it talks about the injuries falling over these years. And it says there are two major categories, but it says 98% of fatal occupational electrical injuries are electrical shock injuries. So the biggest part of the statistic is shock. Yet, when we say 70E and safe work practices, what do we think about? Are those explosions, right?
That's right.
So I put a link in the description. I think I put it in the description. I can't tell anymore if I did or not.
Man.
But the Consumer Product Safety Commission, okay, another very important, a very important part of the pie. They put out reports annually that talks about electrocutions and shock from consumer products. Okay, and one of the things, David, does it take water for you to get electrocuted?
I would say that is a common misconception.
Yeah. I
How's
think so
that
too.
sound?
I think so too. But yet we drive code requirements and whatnot around presence of
Right.
water.
And I actually, to be honest, whenever I'm explaining to non-technical people, I often will, this is bad to do, but I'll often say something like, "This is a waterproofing type scenario,"
Yeah.
right? Because it's an easy way for someone who is a layman or a non-technical person to kind of understand what's going on. However, it is I don't want to say it's incorrect, but it's not telling the entirety of the story.
Yeah. Yeah, it's a partial. So we could say, for example, you might say, like the definition of an overcurrent. Short
Sure.
circuits are overcurrents, but not all overcurrents are short circuits.
Is this a triangle and rectangle situation, or a square and rectangle situation? Not triangle. Sorry, it's been a long day.
It's been
rectangle and square situation where not all rectangles are squares, but all squares are rectangles.
There we go. That's the
See?
thing. Yeah, it's very similar, but I think in terms of the code, not squares and rectangles. I mean, geez,
No.
oh man, come on, David, man. So when you think about the hazards, and now what I was doing was going through the CPSC data, right?
Right.
And they'll talk about it. Now, this is 2000 and what? 9.
That's right.
Okay. And it says now this is from appliances, right? These are tools, toasters, all this good stuff, hair dryers, all that stuff. And it says consumer products over a 3-year period, we're still seeing deaths associated with consumer products. And it is 2009. GFCI has had a lot of time in the electrical industry, yet people are still dying in their homes. Okay.
That's right.
So the other thing that I was looking at was, and I went through the CPSC has a database, okay, and in their database you can search for keywords like shock, electric shock. They categorize things.
Mm-hmm.
So I went down through that database and I found here's some examples. A 33-year-old male trying to unplug the bed from an electrical outlet in the wall, which was malfunctioning, and they felt a jolt to the hand. 28-year-old female presented to the, I don't know what ED, I don't know if that's emergency, whatever, after a patient was walking by an AC unit that was covered in some water. So this is an air conditioning unit, right? And we have newer code requirements around air conditioning. There's Robert from Omaha. No problem, Robert. So here we have the shock emerged from the unit and hit her right arm as she was walking by in the hotel. So there's an HVAC unit that's outside, and we now have some requirements in this regard in the National Electrical Code. And Robert pointed out to me in our discussion today that a shock, so if I don't die from a shock, does that mean it's okay?
Absolutely not. I would still be very unhappy.
Yeah, I'd be very unhappy too. But in some cases, depending upon the damage done, it could have long-lasting effects, right? Emotional
Absolutely.
and other things. So here's a 2-year-old male was home playing with his sister, washing toys in the bathroom sink, and then carrying the wet toys back to their room, leaving a trail of water on the floor. Their mom heard a thud and found the patient lying face down in a narrow path between the bed and the bedroom wall, where there was an open outlet and water from the toys. So here is a child who experienced shock, electrocution, post-traumatic, electric shock, post-traumatic seizure.
Jeez.
In the bedroom.
Yep.
Okay. Now, in this case, we had water, right? So that speaks to that theme. 14-year-old female presents after electric shock. A patient was sleeping in an air mattress. When she woke up and felt shaking, the patient stated that the surge protector next to her bed caught fire and cracked in half. Okay, now this you would think, well, bedroom, that should have AFCI protection on it. Well, you know better than I do code adoption issues, right?
Absolutely.
And then enforcement. So Robert says, read of an incident where a desk was set on a cord. It started a fire and burned the building to the ground. Exactly. Now you can say that's that's more of an AFCI type of discussion, which is when Thursday.
That's right.
A patient was sitting in her chair while it was plugged in. She states that it must have fallen asleep but felt a shock through her body. So I think this is one of those chairs that 91. It's probably a lift chair, right? Okay, that failed. Home, running to the bedroom, she may have grabbed the phone charger from the outlet, at which the point she started crying. Parents concerned for electric shock. That was a possible electric shock. There's a guy working on, our male, 59-year-old male, working on an air conditioner at home. 72-year-old, injury to the hand after he grabbed the end of an extension cord and got a shock from 120 volt. So this is another one. I had, I was just working with a cord this past weekend in my garage, and I can't remember what I set down. I had the cord on the ground. I had some equipment or whatever. I was putting things on the ground, and I noticed that I damaged the insulation.
Okay.
On the extension cord. Do we only use extension cords in garages?
Absolutely not.
Where do we plug extension cords in? Just about anywhere, right?
Anywhere there's an outlet.
Anywhere.
If you're in my house.
Yep. And there was another one. This was the wooden chair bumped against the power strip. Had a finger injury. A mirror with a small light bulb felt a jolt. Upper extremity. So these are all examples. There's another extension cord. This one from to the bed. Okay, the bed to unplug reached over from the bed. So where do we have beds? Beds are in bedrooms.
Bedrooms, sure.
Right. So there's a lot of areas in the CPSC data where they have interesting examples of shock outside of kitchens or within so many feet of a sink.
Yeah, and this is interesting. The particular events that you have pointed out here are all incidents where, they would normally be AFCI technology protecting those particular circuits, particularly whenever it comes to the bedrooms. However, and we don't know if they were or they weren't. But it is crucial to, double down and underline, bold, and italicize the fact that, these events could very easily not be picked up by AFCI technology because they're not designed to, right? These are two separate technologies for a reason, right? So, for example, whenever the Commonwealth of Virginia just recently, they announced that they're going to be adopting the 2017 code. Very happy about that. However, they went from only having AFCIs in the bedrooms to pretty much taking on all of AFCI and GFCI protection, which is great. However, they added provision where you don't need AFCI technology where you already have GFCI technology, which is it was a bit of a compromise between the two parties that one party was pushing for more and one party was against it. However, that type of language furthers a misconception that they can just be hand in hand. They can just one for another. Was it 6 in one hand, half a dozen in another?
Yeah.
Right.
Yeah.
They're the one side of the same coin. That's not true. And
That's
so
true.
I'm glad that you picked out these particular instances where, there could have been AFCI technology that was protecting that particular circuit. However, all the instances are where you need GFCI technology, regardless of where it is in the house, because it is protecting from some type of damage or some type of odd wiring or whatever the case may be. Most of the instances there, I would imagine would be mitigated whenever it came to GFCI technology being part of that branch circuit.
Yeah, and it's important from a technology perspective. The GFCI is looking for current that goes outside of the normal path.
That's right.
The AFCI.
That's the definition, right?
Right. The AFCI
is
looking for that harmful arc that could start a fire that may not trip the circuit breaker. It may not even trip because it could be line to line. It could be, it could still be in the path, but yet cause a fire. And when we think about GFCI protection, the historical perspective is I'm worried about what's on this side of the receptacle, right?
Sure.
AFCI doesn't just worry about what's this side of the receptacle. It worries about what's on the other side of the receptacle as well.
Even from the junction box home run all the way to the branch circuit.
That's exactly right.
I mean, that's a crucial part that I think that some parts of the electrical industry have a hard time understanding, which is the entirety of the point of the list while we have 210.12, all the different means of protecting that conduit going to that home run to make sure we do protect the home run there. And so, we might start going down a little bit too far on the path whenever it comes to 210.12. I mean, you're going to be talking about that.
Well, we're going to talk about that on Thursday, but it's important
right.
to your point to understand an AFCI does not provide shock protection and a GFCI does not provide electrical fire protection, right?
That's right.
Now, I think one of the burning discussions right now in both of these technologies is compatibility, right? The concern is, and we saw this with the introduction of GFCIs back in the 70s, the concern of compatibility with different products, and the code usually takes these technologies on a progression through the structure. In GFC, did you know? And I don't have the numbers on this, but did you know?
Did I know
that the equipment grounding conductor, or the equipment grounding conductor, the EGC, that third prong on a receptacle?
Yes, I'm aware. I'm familiar.
Had a similar journey in the residential home. We didn't require that.
Yeah.
Back in the day, it was 2 wires, right? Knob and tube, hot and neutral. We didn't have an equipment grounding conductor. So we're gonna have to do a program on the equipment grounding conductor, because the journey that took with the 3-prong receptacles was very short-lived. It was real quick. We went from 2-prong receptacles to 3-prong receptacles.
Sure.
But it went to, I think it started in laundries first, and then around swimming pools, and it sort of followed GFCI. Then all of a sudden it was like, look, you're bringing an equipment grounding conductor to all of these outlets.
Mm-hmm.
And that bringing that change in that technology is in the progression is similar to GFCIs. And that's a similar what AFCIs have gone through. But compatibility has always been a concern. And leakage current, right? Okay, it's that whole aspect of leakage current. And I'll tell you what, David, you laugh, but it's a headache for some people, because we'll say, and I love when people talk about appliances in their kitchen, and they'll say, well, when you add up all this leakage current, you're going to have problems with regard to GFCI protection. But my response to that was, go into your kitchen and tell me how many 3-pronged products you have. Most of them are 2. Your toasters, etc. There's only 2 now. Some kind, like my KitchenAid mixer is 3-prong,
right?
But most of those have 2 prongs on them, so there's no place for leakage current to flow.
Well, I have an arc welder in my kitchen. That's because I live alone. And that's just,
I believe it.
No, but one thing I did want to mention here is, before we start getting in too far into the compatibility part, is I think it is important to go through the journey of exactly how we got to, number one, what is the difference between GFCI and GFP, right? And two, because GFCI has to do with the protection of personnel, and GFP is a protection of the equipment. And it's completely case by case to whatever system you're talking about. GFCI is always going to be GFCI regardless of where it is, right? That 4 milliamps and 6 milliamps is going to be GFCI, and it's always going to be. Was it mutually exclusive?
Well, well, here's the thing, though. I'm telling you, there is a There were some public inputs during the 2023 cycle, and there's been
Okay.
debate in this area because the definition, to your point, the definition of GFCI says specifically 4 to 6 milliamps. A Class A device is what they refer to. There
That's right.
are ground fault circuit interrupters that are not Class A devices that trip at 20 milliamps or other levels, right? But and that's like in your three-phase systems and things like that. So there was a desire to change the definition because there is an introduction of this, what we call special purpose GFCI, and Nihad knows all about that. Special purpose. There it is. Nihad El Sharif. So Nihad knows all about the special purpose GFCI and the 20 milliamps. So there was a desire to change the definition of GFCI, but whenever we see those 4 letters put together, GFCI, we know 4 to 6 milliamps, period.
That's right.
Because that's the definition. Now, GFPE, David.
GFPE, David. That was
yes,
my back in high
GFPE.
school.
What is the level?
That's all I got through college.
Yeah. What's the level of pickup for milliamps for GFPE? Is that something that is determined by the code? What?
I have my buzzer here.
Your buzzer.
It depends.
Okay, your pen. All right, so contestant number 1, go ahead.
It depends on the system.
It depends on the system. It depends on the manufacturer. So
sure.
Yep. So the UL standard for ground fault protection of equipment, UL 1053, says you as the manufacturer determine the trip set point, and then you have to meet their performance requirements, which are not equivalent to 4 to 6 milliamps, right?
Right.
Because I can have ground fault protection of equipment on a 1,000 amp breaker set to 400 amps. That's great.
Yep.
That's GFPE. Right. I can also have GFPE on the heat shrink tape from a melt, like an ice melting system at 30 milliamps. Right. And we see 30 milliamps and 100 milliamps in Article 555 for the National Electrical Code.
Sure.
Right. So GFPE is equipment protection. GFCI is shock protection.
Absolutely. Class A. Right.
It's Class A. It's classic. It's Class A device.
Tom.
Yeah.
Where does that 4 to 6 milliamps come from?
Well, David, I'm glad you asked. Okay, it comes from years of college students.
Bring it up.
It comes from years of college students who wanted to get beer money. Okay.
People like me. I'm not in college anymore, but still want beer money.
Yep. You should be in college. All right.
Whatever that means.
Whatever that means. Hold on.
Okay. Yeah, I'm gonna say it's probably like Sligo, man.
Oh, look at this. Look at these 2 guys.
You like those guys, huh?
Man. So we're at
the second row, second slide on the second row.
Charles Dalziel.
All right. So if anyone does not already know any of this, okay, so Charles was a electrical engineering professor from UC Berkeley, from pretty much probably around like the 40s all the way up until the 80s, and so he wrote a study that was called "The Effects of Electric Shock on Man," that was specifically just testing out what the effects are of electricity on humans and animals, which is absolutely something that would pass the ethics standards for collegiate studies today.
Yep.
That's right. So if we keep on going here, so he did studies of the determination of perception whenever it comes to current through the hands. This particular gentleman on the left, absolutely from the 50s, right? Mm-hmm. We're all, Tom and I are dressed as if we're in the 50s today, but these guys are casually walking around here, going to studies where they get shocked voluntarily in suspenders and a tie. That's right, voluntarily. Sure. So we have a gentleman back here administering the experiment, and we have a gentleman up here holding electrodes. As one does, right, on their spare time. How about this on the right? Lovely, lucky lady over here holding an electrode with Dr. Dalziel administering in the background. Sure, just let's get shocked today. That's all I'm gonna do. It's a Friday night.
I need beer
I'm
money
a-
for Saturday.
I'm at Cal Berkeley. Let's go get shocked.
Yep.
Let's do it. So if we keep on going here, this is good. This gentleman here is holding up the electrodes to the tip of his tongue. The first person that told me about this, the first person that introduced this whole thing to me, is below me in the screen. He's the first person that told me about this stuff. I was at the PSEC in Pittsburgh, a lovely facility that anyone should go to, and probably the Houston one, depending on what happens here in a couple months. But either way, and I couldn't believe that you were finding this stuff.
Oh man!
And so yes, this is incredible.
Absolutely.
That these particular people were holding up to their tongue.
I love this one.
This is nuts. Oh yeah, these guys, I don't know if you guys are able to really see it, but these particular individuals, I always thought this guy on the left kind of looks like a young Gary Oldman. I don't know why. But I love the guy in the back here. He's yucking it up. He's having a great time. He's like, how do you feel now?
Yep. How do you feel now?
Feel good? Dr. Dalziel hanging out back here?
Look at him laughing on here. I mean, it looks like they're enjoying it.
I knew that the state of California had some pretty messed up experiments, whenever it comes to the Stanford prison trial and stuff like that. Maybe this is a part of it. Who knows? How are we supposed to know? Either way. But yeah, so this is essentially how we got that particular data. And so if you scroll down here, if you keep it zoomed in, now we're able to see the lines of the data on men and women for particular let go current at the bottom, and a percentage of the particular individuals who were able to let go at the milliamps going from left to right. And so we have the line on the left that's further up to the left being the 28 women, because only 28 women would sign up for this, and 134 men, because we're the dummies, would be on the right here. And
it's a challenge, right?
It's something. It's something.
You have the guy sits down, and what they're doing over in the corner is going, I can hold that. I can hold it for longer than you can. It's like a competition,
Absolutely.
And normal people wouldn't do that.
No, normal people would not do that. And so the let go current, this is something that I feel like this is a phenomenon that I'm not sure if it's well known in the electrical industry. And so the let go current is essentially the amount of current to which if it hits a particular part. I'm not 100% sure on the phenomenon of exactly why this happens, whether it's the electrical current is creating some type of noise or communication.
Are you talking let go as far as why we can't let go?
Let go term. That's right. So I'm not sure if it's one of the two. It's whether the electricity is actually sending mixed signals to the brain, or I think what it's doing, the muscles are actually just seizing.
It's seizing because
okay, gotcha.
But you know why? Because there was research done. I can't remember his name, but he did put current through a frog's leg who was dead. Right? The frog is dead, and they could contract the muscle. So it has nothing to do with the brain or anything like that. It's just contracting the muscle. And then the frog who was dead hopped into the water where it sunk like a rock.
Okay, this is way off base. Okay, do you remember I think it was the Warner Brothers like Looney Tunes frog that would get up and sing "Hello, My Baby"? What was the guy that frog's name? I can't remember.
I don't know.
It was I don't know. But
that was a good
either way, that's what I'm imagining now. Just going with the top hat and the
hello, my baby. Hello, my darling. Hello, my ragtime gal. You ain't right.
Anyway, so the point is that your muscle seize up and you're not able to let go, which is essentially the let go current. And so anything before that let go current, you're able to let go. It won't feel very good. But anything after that let go current, your muscles seize around and you're not able to actually control your body to be able to get away from it. And so if we move on now to the next part, is that, if we look here at the 60 hertz cycle for men and women in the middle, on these, this third and fourth column, and then if we look at the fourth row and fifth row for painful shock, we have for men 9 milliamps and for women 6 milliamps for painful, but they're still able to let go.
Right.
And if we go down a little bit farther, for the let go threshold being 16 milliamps for men and on average 10.5 on average for women. So this is where we get the 6 milliamps. It's from empirical data that probably should never be conducted again.
Yes. Yeah. And you know what? And what preceded this, I'll tell you what,
Yep.
what preceded this research was research done by a gentleman back in 1939, electric shock as it pertains to the electric fence. This preceded Dalziel. And David, the 4 to 6 milliamps is in here.
No kidding.
They tested on children because they wanted to understand. Here's what was happening. Farmers, because back, they like, hey, we got this electricity, so they were running this electric fence around an area they had cattle in, and kids were reaching up, grabbing onto the fence, and getting electrocuted. So then a manufacturer said, I'm going to have a product which is going to be pulsed DC, and they said this will prevent electric shock. But then UL had to list it, and they said, we don't know if that's going to prevent electric shock. We don't know the impact on the body. So they did research, and they put this report out. And I tell you what, I was just I'm
20 years
old
at the time.
I was shocked. Okay. Look at this. The chief resistance of the body in electrical circuit is the point of contact of the circuit. So they did measurements of impedance of the body. So you'll see the data associated with that.
Sure. Body
resistance of the individual, sex, height, weight, all that good stuff. But I'm looking for the.
Well, while you look, I want to let in the audience on something very quickly. Michigan J Frog is the name we're looking for.
Is that it? Michigan J Frog.
Michigan J Frog. So if anyone had that, please come and collect your $1.41.
$1.41. No. You've got to earn the $1.41. So remember, don't give anything away here because
yeah.
Jeez, oh man.
I'm gonna keep on giving stuff away until you actually announce what it's for. $1.41.
$1.41. Jeez, oh man. So I can't find it, but they were in here. There was reference to the age of the kids that they were, because they said what was funny was they said they tested on death row people. They tested on death row people. But they said these people were older, and they tested on cattle and stuff like that. And they said, but we're really going after the 2 to 4 year old child. So then they said,
sure.
Well, you know what? They realized they have to test on children to get it right. And that was just like, wow, you would never do that today.
Why not?
Why not? Yeah. I'm sure that when I was a kid, they probably would have said, yeah, let's do it.
So, yeah, that sounds like a Roger Dangerfield thing.
Yeah.
Exactly. I respect my dad used to sign me up for electrical experiments. Save the cattle.
Save the cattle.
Dr. Vinny Bots.
So let's get back to so let's fast forward. Now we have GFCI. That's GFCI has been going in the National Electrical Code. It's been expanding in the National Electrical Code. Compatibility with end-use products has been and still is the concern, right? But if you think about what a GFCI does, it looks for current going outside of the normal path. And when it exceeds a certain threshold, it trips.
Absolutely.
So in my mind, when someone says, Tom, your product isn't compatible with my cup, I plug this cup into the wall and it trips. You know what my question is?
My question would be, how much leakage current is that cup putting off?
And where's it going?
That's true.
When it leaves the toaster, right? So I look at that and the equipment grounding conductor, unfortunately, in some products, and we saw this in the National Electrical Code. If you look, Article 200 is the article that focuses on the grounded conductor, right? That's the neutral, but we call it a grounded conductor because it might not be an actual neutral. But in any case, they'll tell you that you in some cases, like in 404.2, if I go back to 404, 404 is on switches, right? So 404 is titled switches. 404.2c is an interesting section in the code because 404.2c talks about where you need to pull a grounded conductor. And it says there's an informational note. There you go. So open up the look at that. That book's like freaking brand new, man. Jeez, oh man.
It's because I just got from the office. It was under COVID lockdown.
You said that last week. You're supposed to have tabs in it already. I mean, here's what you do, David. You take the book, take it outside, drag it through the mud, throw it against the wall a couple times, tear a couple pages, crinkle things up a little bit. There you go. It's got to look used.
It's good to go now.
It's good to go.
It's broken.
Jeez, oh man. So it says the grounded conductor shall be extended to any switch location as necessary and shall be connected to switching devices that require line to neutral voltage to operate the electronics of the switch in the standby mode and shall meet the requirements of 404.22. If you look at 404.22, it's a relatively new section. It says electronic control switches. Electronic control switches shall be listed. Electronic control switches shall not introduce current on the equipment grounding conductor during normal operation. The requirement to not introduce current on the equipment grounding conductor shall take effect January 1st, 2020. Why did they do that? Because there are these occupancy sensor switches, and we talked about this during the Alexa and the wiring device discussions. I didn't mute her. So I got to make sure she doesn't do something. So what happens is you have an existing light switch where you only have a hot conductor and an equipment grounding conductor.
Yep.
You change that light switch out with an occupancy sensor type of device that turns the lights on for you and off. Okay. Well, it needs powered. And if there's no neutral there, if there's no grounded conductor there, where does it derive its voltage, 120 volts, to ground, to power it? From the equipment grounding conductor, which is not good, right? Because it puts current back on the equipment grounding conductor. And what does that do? When you start adding those up, it could trip a GFCI, right?
Well, I mean, that's not the worst case, right? It can trip a GFCI,
right.
But it's just a hazard in general.
Correct. Right.
Is it like a non-current carrying conductor?
Yep.
It is not intended to carry current.
That's exactly right.
Full stop.
And then here's what happens. Here's what happens though. For example, dryers. Okay, the dryer, at one point, we did not have to have a neutral pulled to a dryer. Years ago, you had two hots and an equipment grounding conductor. Done.
Right.
Right. But then what happened? They start putting electronics on dryers. Mm-hmm. And the manufacturers of dryers now had a 120 volt circuit. And what did they do? They just picked it off of the equipment grounding conductor, and you can't do that. So then they required that grounded conductor to be pulled to that appliance so that the appliance manufacturer could use that. And now we have GFCI protection for dryer circuits, and we don't have compatibility issues because the manufacturers are using the grounded conductor for that return path. So now we move over to other types of because we're expanding GFCI, and the concern is around the leakage currents, the standards associated with that, how are different manufacturers using the equipment grounding conductor as opposed to what they should be using the grounded conductor, and all these other concerns. And then you have the higher frequency noise currents, right? And what do they do? What do you do? Circuit design. If I'm designing a circuit, I remember in school we had to do a amplifier. And I tell you what, David, I could not get it to work. And you know what I did? I just kept I started putting capacitors anywhere I could, because we were on a time limit, right? We had to get it done by the end of the day. So I just started sticking capacitors to ground any place I could. And it finally worked because I was adding filters into this to get all this noise out. Well, if I don't have a conductor, where am I going to filter it to? The equipment grounding conductor.
Sure.
So so the compatibility is always a concern, but it's changes like this that force changes in wiring practices, like AFCIs. AFCIs, when we first had AFCIs, they had 30 milliamp ground fault protection in them. there were a lot of people doing shared neutrals, and all of a sudden you couldn't do that, right?
Sure.
So technology and changes in the code quite often changes wiring practices and how products are manufactured.
And here's the key point: for the better.
Yes, that's true. For the better. For the better. So we have the National Electrical Code continuing to expand, right? And you have the National Electrical Code continuing to expand GFCI protection. And in 210.8, we saw a significant, in the 17 code and the 20 code, we saw 2 cycles of significant increase in shock protection, unfortunately driven by deaths.
That's right.
And that's what frustrates me a little bit. Like, for example, when I think it was Fred Hartwell, God love him. He stood up and he said exactly, he was spot on. He got up and he was speaking about GFCI protection, and he said, speaking against GFCI protection is like farting in church. And I thought, that is, it's a true statement. I mean, when you start talking about against shock protection, or when you say, I want substantiation, what you're asking for is a body count. And so I struggle with that, because I think we understand electrical hazards. We understand the hazard of shock. And the question is, when you understand the hazards of shock, when you look at the CPSC data of people still dying in their own homes due to electrocutions, the question is, what do you really need to say, look, we have the technology. Why wouldn't you GFCI protect circuits, especially in a residential dwelling unit where you should feel the safest, right?
Well, I mean, I'll talk to people on a daily basis that do the cost-benefit analysis, because it is in their best commercial interest, and that's part of the job whenever it comes to my role. But I have a hard time with it, just because this. I'm not going to name what state it is, but there is one particular state who insists that the national deaths aren't relevant enough to their state. They need state-specific deaths before, and it has to be above a certain point to justify the change. And it's like, okay, so how many of your not countrymen, but your fellow residents of your state, and if it's not above this arbitrary number that you are deciding, then it's kids, whatever, adults, whatever, workers, maintenance people, I mean, hasn't hit the number yet to be considered, enough to change, which is wild.
I know.
That's all I have to say about that.
And it's frustrating, especially, and I know you get involved with this as well, and I know I did in the past. We look at sustainability, and we look at the decisions that are made for creating a green structure, or creating a sustainable environment with regard to electric vehicle chargers, and photovoltaic systems, which will help the environment. It'll help avoid. It helps the gas and the CO2. All that great stuff.
Right. That's right.
But then I was in a meeting one time, and we were trying to get a better cost from banks. Like, for example, if I was going to build a green structure, a LEED building, right?
Sure.
The goal, what we were trying to do is, we were looking at investors, we were looking at the capital market, saying, look, we should get a better interest rate on my loan to build a green structure, because it's going to impact the environment, which will, all that great stuff. Okay. And the gentleman that we were talking to, the bank that we were talking to, said, look, I agree with what you're doing. I agree with the environmental impact. I agree that we need to change how we build these structures. We need to make more sustainable structures, etc. It'll help mitigate the flooding in the future and all these great things. But he says, I have a problem right now. I have people building a structure I have a flood, a hurricane take out a structure, and they rebuild that exact same structure in the exact same location to the exact same inferior standards that have either been hacked or chopped up due to local amendments or not even enforced at all. And he made a very valid point. And I said that, we have to really look at everything from a holistic perspective. You can't talk about the environment and not talk about life safety.
Right.
They have to be treated together. It has to be a safe and sustainable structure, not one or the other.
Yep.
So we changed to accommodate technology. We had changed 404.22 and the compatibility. The National Electrical Code is continuing to expand. We've got Article 555 trying to address shock hazards in water, right, and around marinas.
Yes.
What I like about what we did in 555 is we did a tiered approach to safety. We did 100 milliamps at the main or the feeder, 30 milliamps out to the boats, 4 to 6 milliamps on any receptacle outlets. That tiered approach, I think, was a very good approach with regard to advancing safety in the National Electrical Code. I firmly believe there is a place for GFPE in shock prevention, because GFPE will take the problem offline before somebody can touch it. If you think about an internal fault, either in an HVAC unit or an internal fault in a boat, an internal fault, a fault on the wiring that's going out to a dock,
right,
those fault currents are not going to be 10 milliamps, 5 milliamps. Those fault currents are going to be significant, much greater than 30, probably much greater than 100 milliamps. In one marina, our services division was out there upgrading. We put a 100 milliamp device at the feeder going out to a dock, which didn't have any boats in it, and it tripped. We took the 100 milliamps up, we put it at the 400 milliamps, it still tripped. We took it up to an amp, it still tripped. We took it up to 2. It was over 4 amps of ground fault current, leakage current going somewhere on that dock. And it was due to miswiring and damaged infrastructure on the dock. So a GFPE device can make you aware of a problem, isolate the problem before somebody touches it. And the closer you put it down to the loads, the better off you are. From a you want to take out something, you want to take out a specific load, you don't want to take out a feeder, or you want, so if you can put either GFCI or GFPE down close to a load, it helps isolate. What are you smiling about?
Sorry.
What?
I'll tell you in a bit. I promise.
All right. Yes, Robert from Omaha, doing the same thing over and over and again, expecting a different result is the definition of insanity. That's exactly. And you know what? That's what that person. I forget what bank he was with. And he was the one who inspired in me the desire to drive I called it leadership and safety through design, a lead equivalent for safety. I firmly believe that if, from a future perspective, think about moving, progressing from, you have the code, you've got the 2023 cycle is looking at expanding GFCI protection, right? We have the 2023 code is looking at saying, hey, it's not the receptacle that's the problem. It's the appliance that's plugged into it.
Right.
Right. So the 2023 code is going to say, it's not that the receptacle is within 6 foot of the sink. It's that the appliance is within 6 foot of the sink, which that's a big deal.
Sure.
Because now you're going to look at where my receptacle is. I could have a receptacle that's 12 feet away from the sink, have a 6 foot cord on the refrigerator or whatever it is, and have the refrigerator within 6 foot. Now I still have to protect that receptacle. That's exactly because the appliance is within 6 feet, because that's the hazard.
Yeah. I mean, that makes sense to me, to be absolutely honest. And so that's something we're looking at right now for 2023.
Yes.
Yes.
Gotcha.
In
fact, that made it through first draft.
speaking of 2023, there might be a new a person on code making panel 7.
Might be.
Who knows?
You're already on it, man. And so you were approved.
That's right.
Congratulations for
Feels
getting
good.
on Code Panel 7.
Can't wait.
That's
Can't
right.
wait to
And that's
contribute.
marinas and all that jazz. So you're going to be right in the thick of things. And they're doing some good work on Panel 7. And I'm looking forward to watching you shine.
That's the hope.
Yes.
I'm normally pretty dull, so I mean, we're going to need a lot of polish before I shine.
Absolutely right. You're going to need a lot of polish.
That's right.
So where do you think the future is with regard to shock protection?
I'm glad you asked, Tom. I'm currently watching what's going on here with the low voltage solutions that are being introduced to the code. There's a lot of very interesting ideas that are going on that Eaton's part of, and also outside of Eaton, that could, to be absolutely honest, revolutionize the entirety of the electrical industry and completely change the way we do power distribution. Not only whenever it comes to high power situations like in industrial and commercial, but it could change the way houses are built all across the country.
Yeah, if you think about LED lighting, you look at a lot of what we use, phones. What do? We plug a phone into a small cord that goes to a jack, which converts it from the DC voltage to the AC voltage. We have computers that plug into that you have a low voltage that goes to this nice big transformer that gets it to 120 volts. So I think LED lighting is probably the first area of opportunity for low voltage DC, because what's the shock threshold? If you look in 70E, 70E tells us in I think it's is it 110 or is it, I think it's energized 120 maybe. Nope, not 120. 130. 130.1, which is work involving the electrical hazards, tells us that 50 volts, it says when energized electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts are not put into an electrically safe work condition, etc. So 50 volts is that threshold from a shock perspective. You can do a lot with 50 volts to power different things that we have. I mean, my phone, my computer, my televisions. I think I agree with you that in the future, we're probably going to be leveraging lower voltages, but I think, and I did a program, I wrote an IEEE paper on this, leadership in safety through design, that whole LEED equivalent for safety, the aspect of giving you points for building a structure above and beyond bare minimum code requirements. I think that has merit, and I think that you could have an easier time getting banks and insurance companies to recognize that when you take a structure or even a community, because I did a safety summit one time with a bunch of the right people from Federal Alliance for Safe Homes and the National Fire Protection Association and a bunch of others, NFPA, and also NASFM, the National Association of State Fire Marshals. There was CARI, the Community Resilience. So all of these different organizations recognize that even as a community, for example, safety in a community, if you set up a neighborhood watch, if you have a public phone, an emergency phone in a neighborhood, that if you're out on a jog or you have an accident or you have an emergency where somebody is attacking, you can reach and go to contact somebody. All of putting lighting on the outside of your house to illuminate those dark areas where somebody may use to leverage to hide while they intrude in your home. Adding a security system, smoke detector systems, all these different things. There are things you can do to go above and beyond bare minimum code requirements that you wouldn't be able to justify to get 2/3 of a vote, right? But from an insurance perspective, And from an investment, from a bank's perspective, if you're going to go above and beyond, you're a safer investment. I firmly think that that whole concept of a lead equivalent for safety. I mean, I've had this for quite some time, this drive, and I've managed to get. There are things that UL is doing right now that I like to think maybe a little bit of what I was saying resonated with to help drive them in that direction. But they're looking at something similar. They're doing some things. Other organizations have done some things. So I think that, in my opinion, from a shock and fire and life safety perspective, unfortunately, the way we operate, you need financial payback. We look at return on investment, right? And electrical safety is not something a home builder sits down with a home buyer and says, let's talk about the options for electrical safety in your home. I would like to talk to you about AFCI protection. Would you like AFCI protection on more than just the bedroom circuits, ma'am? No, okay.
Normally, I do that in my fake realty license. I do that. I can't sell any houses. I don't know what's going on. Everybody is out in this red hot market. I'm not able to sell any houses because the first thing I mentioned is electrical safety. What's going on?
Yeah, I don't know what it is, man. I don't know what it is. But we're not. What they want. Everybody wants to talk about is granite tops, hardwood floors, and chandeliers and things like that.
French doors.
French doors, yeah. That's the stuff they want to talk about. Where we should.
I'm just trying to get French toast, let alone French doors.
French toast. You ain't right. You ain't right. So I think from a future perspective, I agree with you. Low voltage type of solutions are, power over Ethernet. Those type of technologies are going to start creeping in to the infrastructure. And I don't know what the acceptance is going to be, like in dwelling units and all the other good stuff, because we're so tied to a 120 volt receptacle, right?
Yep.
I think, though, that like things like LED lighting, lighting areas, but even lighting. I mean, everybody, you go to the store and you say, I want that lighting fixture. If you brought it home and tried to put it in and you go, what's this little 10 base T wire up here? I need 120 volts. And then after the fact, you can't retrofit that in. So those are the hurdles that technology has in our building infrastructure. And I think we all recognize some of those challenges, but they will, I believe, start creeping in. And then we can't forget about the hierarchy of controls, risk controls in NFPA 70E in 110.5H3. In 70E 110.5H3 talks about the hierarchy of risk, meaning that I can design safety in. I can substitute equipment. So substitution could be that instead of a 120 volt solution, I am in a 24 volt DC solution, right? I'm achieving the same goal, but I am substituting on different technology and putting in something that doesn't present a shock hazard. There's engineering controls, meaning I make the interlocks on doors. If you open a door and it de-energizes, we have different controls like that. Awareness, what we're doing right now, we're raising awareness on shock and hazards. So there's the hierarchy of risk control and the methods associated with that from 70E, I think can help us shape the future from a safety perspective.
I agree. And I'm glad that, we are able to cover this for the first week of Electrical Safety Month. And, first presentation we do here with you all is the first Tuesday being GFCI. And my understanding is the next one's going to be AFCI. And then we'll just keep on rolling in Electrical Safety Month. And Christmas in May.
Christmas in May. And David, you and I agreed. And I talked to Robert from Omaha too. 1 hour is going to be our new limit. Which
we're already over.
We've just hit the 1 hour mark. Would you say?
Right. We're already over.
We're already over, but that's okay because we're not going to go to 2 hours anymore. We're going to 1 hour, and we covered shock protection. We talked about Dalziel. Can't talk about shock, understanding shock if you don't mention Dalziel. We talked about the cows and the shock of the fence. We hit technology. We talked about the hazards. We talked about the technologies, talked about the compatibility, the journey that GFCIs have taken. We talked about the code, the National Electrical Code, how it's expanding. Gave a little bit of insight into the 2023 code and what we're doing there with regard to the location of the appliance being the hazard, not the receptacle. And we talked about the future. We talked about the leadership in safety through design, a passion of mine. We talked about technology, the substitution, hierarchy of risk. So I think we gave a good overview of shock, and I'm pretty happy. You?
I'm very happy. I think that tingling sensation that we had about Electrical Safety Month. I'm glad it was that tingling sensation, and I'm glad everyone came out like they normally do. It seems like we're building some momentum here on the hashtag Eat Tech Talk Tuesdays, and so thank you very much for everyone coming in. And we have any good stuff?
Oh, you know what, Felix? You know what? And we're gonna do this one. Felix brought up the step and touch potential, and you know where that comes into play is IEEE Standard 80 really gets into the discussion of step potential, because we're talking about substations, right? And you have, Felix, I'm putting that on the list. In May,
we're taking requests here. This is good stuff.
We're taking requests. So Felix requests step and touch potential. And what we'll do, we'll get a session. I will try to find somebody else as well that's very well versed in substation grounding and bonding, because there's a lot of things. There's testing for step potential. There's tests that we do at sites for substation grounding to make sure that we have the right grounding and bonding. So I'm glad you brought that up, Felix. We will definitely do that during this month of May, because we're going to exceed the Tuesdays and Thursdays. Yeah, we're going to exceed the Tuesdays and Thursdays. I'm reaching out to a team of Buck 41s, and we're going to create that Buck 41 club, or whatever we want to call it. And
the bank,
yeah,
the piggy bank.
You know what? I like it. And you know what? Here's the goal. Oh, I can't. We got to talk about this offline.
Okay.
Because I don't want to share anything yet.
Don't forget the equipment grounding conductor. Have a whole show about the equipment grounding conductor.
Oh, yes. We got the EGC, equipment grounding conductor. We will focus in on the equipment grounding conductor. Bonding for swimming pools. You know what? I didn't do it. I did have a planned session for swimming pools, and I was going to reach out to Donnie Cook, actually, to help out with that one. So
yeah, I was going to say either Donnie Cook or Dean Hunter would be good at that. Good for that.
Oh, yeah.
Or I remember there a few years ago, it was the first time I ever went to the North Carolina, the electricity.
North Carolina Institute.
Thank you. And they had a particular, I think he was like a forensics engineer, and he was going over essentially the fatal injury, of a particular lifeguard, like a young lady, and he was going over all the different things that had to have happened badly for that to happen. And then right now, if you pay attention to anything in North Carolina, a lot of the stuff that's going on there, they're going above and beyond the code for bonding for swimming pools. So
there was a period of a lot of deaths and when you think about a swimming pools, here's what happens. It's just like marinas. You dive in and I see you struggling. I go and I get a beer and I watch. No, I jump in too, right? To save you. And then I struggle. So that's what typically happens. It's like one after another after another. And in fact, in the one case, a family of 3 perished. It was, I think it was the granddaughter or whatever, and then the grandmother and the grandfather. It was something like that. It was terrible, absolutely terrible. So I'm just telling you, David, if we're ever at a pool and you dive in, I'm not diving in,
buddy. Icy light time. That's right. I get it. Time for some icy lights.
It's time.
What was that Weirton one you had over there?
What?
They have a Weirton beer? From Weirton. Is that right?
It's a Weirton. It's an Iron City beer, but it's Weirton Steel.
Very nice.
Yes.
You know what the high school is at Weirton's called?
Just say that again.
The Weirton. Okay, so for
We're
anyone who's
high.
not from. It's right. It's okay. So if you're not from the Western Pennsylvania, Northwest Virginia area, there is a little town in the northern panhandle of northern panhandle of West Virginia. It's called Weirton, and the high school is titled Weir WIER High. So
We're high.
I have no other comments for that other than that is. And also in southern West Virginia, I will mention there's a little town called Polka, Polka, and their mascot, the Dots.
Polka dots. Oh, that's just wrong.
There you go.
That's wrong.
Some West Virginia trivia for anyone that's out there.
Absolutely right. Mr. Nihad El Sharif, yes, the Buck 41 Club, the mysterious Buck 41 Club, you are going to love it. So we got bonding for swimming pools, we got the equipment grounding conductor, we have the step and touch potentials, and we're doing everything we can to try to we're going to try to keep these in 1 hour sessions. Now, what we might do is my suggestion would be, David, if we're going to do if we're going to do a 2 hour session, we're going to do a 2 hour session, and I'm going to try to get CEU credits for it.
Yep.
But now we're at 1 hour and 15 minutes. Robert is right. All right, we got to shut this program down. I could go for all night. So
you want to get a beer? Let's go get a beer.
Let's go get a beer. You're buying.
All
right, everybody. Yep. Thank you for tuning in for an hour and 15 minutes of pure education.
That's right.
Welcome to May National Electrical Safety Month. I'm looking forward to a lot of little sessions this month, and I've got a lot of people lined up. So stay tuned. Check out thomasdimitrovich.com, www.thomasdimitrovich.com. I've got a calendar up there of events. I'll put that associated with this link too.
That's right. Don't forget, if you're on, ever checking out YouTube, go on tomdimitrovich.com.
Yep.
Or Thomas Dimitrovich, that's the channel name. And then go ahead and subscribe there, do all that stuff, like the video. And also don't forget Michigan J Frog. That is what you need to remember from this video today.
Hello, my baby. I love that. And then he opens it up and he puts it on the table, and then he's like trying to show somebody, and it goes.
Yeah, there's no electricity. They took off the electricity. The muscles aren't spasming anymore.
Oh man. All right. Thanks everybody. And Chris Foland, Nihad El Sharif, Felix Sandoval, you are awesome. Chris Foland, what does a grounding electrode system do since it doesn't have anything to do with breakers tripping? Ooh. We're going to talk about that. We're going to talk about that one too. Tamaki, thank you for joining us. Not only promoting safety, but also connecting electricians around the world. Absolutely. We got Japan. We've got Felix from Colombia. Man, a day. You know what? I even switched from French roast to Colombia coffee because of Felix Sandoval. Now watch. There's going to be somebody from France who's going, wait a second. Bonjour. He's not drinking French roast. Anyway, Yosemite Sam. All right, everybody, we got to shut this down. Thanks for joining in. Thanks for what you do for electrical safety. Thanks you too, David, for what you do for the electrical industry and electrical safety. I really appreciate it. Stay safe, everybody. Adios. Good night. I'm hitting end. I really am right now. I'm doing it right now.
Smash it. I'm
smashing it.
Give it all you got.
1 hour and 20 minutes, Robert says. All right. This is for real now. Goodbye.